How's it going? This is a video, all those model flyers out there. So, just a shout out to Bruce, who's encouraged me to put my videos together and put them onto a channel. So this is video number 1. So the format, we're going to look at old stuff given to me and we're going to analyse why it actually breaks. So this is my shed, and I'll be turning to you, giving you a bit of an insight into the video. You're all aware of the plane, which is the Bruce Goose model plane, which we're presently underway putting together. You can see that we've got a float here at the front, and we've got some floats on the edge of the wings, and we've got a little tail fin which is used for flight, or keeping it straight in the water, and also helps it flying. So what we're going to do today is we're going to replace the propeller here with a bigger propeller. So what I need to do is have a look at my tools and find something that will fix it. So probably need a screwdriver or something of that nature to go through that hole there, and then we'll be able to unscrew it and then we'll get it going. So let's see what we can do. We might use a nail, how's that? And I'll pop that in there, hold that this way, and then spin it. It comes undone. So you've got a couple of bits for this. If you haven't seen these undone before, it's just a cat screw, and we've also got a little flange. And the nice thing about this camera is you can actually put stuff up on top of it. So according to Bruce, these blades are an extra inch longer, and they are, for $1, the best upgrade you can do for an AXN. So here's the old one with the little weighting tag on here, and there's the new one. And if you can see how much bigger they are with regards to the length, so there's that much difference in length. And we did some maths, Bruce and I, we did some maths on the blade sweep. So the circumference around the outside is what's called pi d. So pi is 1.2 for easy sake, 1 decimal point, and d is the diameter. So the difference from there to there times pi. For example, if this is 6 inches, 6 times pi, which is 3.1, which is 15.5. So the outside will be 15.5 inches right around the outside of this. Now do the maths on this one. So this is a 5-inch or 6-inch prop, and this is a, so we've done the one for this 5-inch, so the 6-inch prop, if we give that 6 times 3.1, we get 18. So the difference between 18 and 15 is 3. So 3 into 15 is 5. 50 is 20%. The circumference is 20% greater. But what we're really interested in is the area, the swept area of that extra bit there, because the area is the radius, pi is pi r squared, so the radius squared times pi. So the radius from 6 is 3, for a diameter is 3, 3 squared is 9, whereas this one here is 2.4. If we round it down to 2, 2 squared is 4. So the difference between 4 and 9 is about 50% greater. So the actual area for this little propeller is, let's say it's 50% greater. You might think that little bit there gives you 50% more wing sweep, but the other thing you have to realize is that it goes faster as it gets to the outside here. So the other thing is that tiny little bit of there sweeping at that speed, which is 50% more, so the lift you get and with the speed. So you could get a factor of a 50% increase in power, extra dollar. Let's say the motor is able to handle it, which it is, and so you've got a 50% increase in power just by putting an extra inch on the blade. So we pop that little thing out there, and then the blade goes on like that, and then we'll keep this for a spare. So technically we've got to watch out for a couple of things. This will hit the bottom, so you can see how it's getting very close to the bottom there, whereas the old one sat quite high up above it, half an inch above. Right, so we get off the camera the little bits and pieces. We'll put that sprig on there so it doesn't quite fit. And the other side is, which way does this go? Does it go that way or that way? So I think it would fit better in there. And then put that on top, and then that screws up over the top of that. So we'll give that a try. With regards to the extra power to get this AXN off the ground, and we'll do a water test. So that's my first video, so the next video will be doing a water test. So there you go, that's on, and we're all set, nice and sweet. Okay, so I'll just get back up onto the bench. So that's our first video. So now we've put a bigger prop on here, and we should be able to get this thing up and running and flying. I think, yeah, we'll just see if the bigger prop makes a big difference on that flight. The other thing we can do is add a bit more, just improve this step. So anyway, we'll give it 50% more power, and we'll see if that gets off the ground. Okay, well, back to the bed.